Hi folks, Matthew Lanigan here with Baywa RE. We're just going to give it another minute or two before we begin the webinar. I just see quite a few people still signing in, so just a couple more minutes and we'll start things up. Thanks so much. Hi guys, Matthew Lanigan here again with Baywa RE. I'm the Chief Commercial Officer with Baywa, take care of sales and marketing. Really thank you all for taking the time to spend with us today to learn a bit about Fortress Power. Just a couple of housekeeping notes. Please, if you have any questions, there is a box down in the right corner. Please just enter them in there. We'll do our best to get to them all. We will answer them at the end. Something else, this will be recorded, so if you need a copy of it or if you're missing this, please just reach out to us. It will go out in the July newsletter, and your reps will also have it in advance if you need a copy. Continuing education is a super important thing for Baywa internally and with our customers as well. So we really do appreciate you taking the time to spend with us. And I'd like to introduce John Cromer, who's the applications engineer with Fortress Power. And John will be walking you through the presentation. Thanks so much.
Hey everyone, welcome to the program. We're going to just give a product overview. I'll let you know some important things about our existing product line, as well as some recent announcements, some new products that are now available. Just some background on Fortress. You know, we make UL listed. Let's see, where'd my presentation go? We make UL listed 9540. Lithium iron phosphate batteries. We have a headquarters that's just north of Philadelphia in Southampton. We have a solar array on our roof. Our test lab includes about 9 different battery inverters. We develop closed loop communication between our batteries and various inverter products. Not all battery inverters support closed loop, but if it does support closed loop, we develop it. It's a two-way conversation, so we reach out to a lot of manufacturers, try to make our batteries as compatible with as many inverters as possible. This includes, compatibility with 48-volt battery products. There's 2 different levels of compatibility. We'll be talking about that in a few slides, but we have shipping and logistics centers on the coasts as well as in Texas. And so, when you need batteries, out in, the West, there you don't have to get them shipped all the way from Pennsylvania to get access to them. We do ship globally, and we have some utility scale or really municipality contracts for distributed batteries. And we also sell to residential and light commercial application. Let's see, some of the things that make Fortress different than other companies is we really, everyone says, we pride ourselves on customer service. We try and have a technical support department where if installers or even customers have questions about their product, they can get a quick turnaround on the answer. Often that means placing a phone call. We have other support resources to help customers along. But we definitely believe in being a company where you send us an email, we can get you a response. You call us on the phone, we get you in touch with who you need to talk with. Get even just the preliminary design questions out of the way before the project gets in the field, and also support the installers when they're in the field. So you get customer support with us, as well as top shelf batteries, and we know our products inside and out, so are always happy to answer questions you have. Bayware is one of our distribution partners, and so we follow that distribution model. We don't sell directly to the installer or to the homeowner. Our batteries qualify for various kinds of solar financing packages, and our main products are the eVolt and the eFlex. And the way I would describe it is the eVolt is our flagship product. It's our most popular product. It's cost effective. It is the lowest dollar per kilowatt hour out of the two. It's very simple to install. It's a battery that's large enough and designed for your 8 kilowatt to 9 kilowatt battery inverters. As far as the battery component of the inverter, if you size it with an 8 or 9 kilowatt inverter, that is the perfect size for it. So if you just have one battery inverter and you want one battery and you just want one set of conductors between the battery inverter and the battery in a very simple install, the eVolt is how to go. I mean, if you know what you're doing and you have an easy to access job site, you can literally uncrate the eFlex, wheel it into place, run one set of conductors between the battery and the battery inverter, press the power button and program the inverter, and you're fully installed and commissioned. So, if you know what you're doing, it is possible to design or really install and commission an eVolt project in 1 or 2 man hours. So it's simple, it's cost effective, it's warranted for 10 years for more than one cycle a day. So any kind of electric rate you have, that'll be good for its 10-year warranty. And that larger product size lends itself really well to cost-effective economies of scale. The eFlex battery is a newer product line that has a little more robust of a battery management system than the eVolt, although that's changing with a new product announcement. The eFlex is the rugged battery line. If you're putting your batteries in a barn, even an outdoor installation, now you still have the battery terminals that stick out through the battery enclosure, but the enclosure itself is an IP65 enclosure that prevents humidity and dust from getting into the battery. And also the aluminum case is very rugged, and it also acts as a heat sink. So we put these ridged vents both inside and outside the battery case that does a lot better thermal management than your typical battery. So the case is upgraded. It has a robust battery management system inside of it, and it does closed loop with Solark and Schneider, Sunny Island, and a couple other inverters as well. So it's just the eFlex you use when the eVolt doesn't work. When you have to get the battery up or down the stairs, if you're doing it in an extreme environment or an outdoor location, or you don't have the space on the floor for the batteries and you want to do wall mounting or server rack mounting, the eFlex is the more flexible solution. The eFlex also has a little bit more surge capability than the eVolt per kilowatt hour. And what that means is often when you could do one eVolt projects, but the budget is such that the customer cannot afford a single eVolt, you can usually get away with doing two eFlexes instead. And while the battery per kilowatt hour is a little bit more expensive, two eFlexes has an upfront cost that is less than the budget needed to purchase one eVolt. And so even for slightly smaller projects than one eVolt, the eFlex, provides a little bit of design flexibility there. So whether it's for wall mounting or extreme locations or slightly smaller project than the eVolt, the eFlex is the everything else solution when the eVolt doesn't work on its own. Sometimes that might be if the project's in a basement and there's a floodplain and the battery has to be up off of the floor by a certain amount. It may just be easier to do an eFlex install instead of an eVolt. Now, the eVolt has recently gotten much more easy to install because it's gone through a second generation product update. The product is called the eVolt Max, and we've basically taken the eVolt and rearranged it slightly. It's still the same voltage and amperage, so the spec sheet is about the same. However, we've upgraded the battery management system. The eVolt Max now stacks up to 20 units. That means you can parallel up to 20 of these eVolt batteries together. And when you go and look at what batteries we work with closed loop that also scale up, what that means is the eVolt starts as a residential battery and it scales all the way up until about a 80 kilowatt output commercial three-phase 208 battery project. So there are some battery inverters out there that will scale into stack into groups of 9. These are all commonly 9 kilowatt battery inverters. 9 times 9 is 81 kW. And so for commercial projects up to about 80 kW, the eVolt represents a very easy and very cost-effective installation that kind of fills an unmet demand for these smaller commercial demand management projects where you might put just the refrigerators on backup and then provide demand management for the building. The eVolt Max does that as well as residential applications very well. So the eVolt has some closed loop limitations. It really only supports the Solarc and Schneider inverters up to 2 eVolts in parallel to get that communication between the battery and the inverter. You can have eVolt projects that go up to 12, but they won't communicate directly to the inverter. It's all based on voltage. The eVolt Max is more like the eFlex in that it supports communication with more than a dozen units. In the eVolt's case, it's up to 20. So you can build a 370 kilowatt hour battery bank and still have the batteries talk directly to the inverter system. That for the eVolt Max, that includes the Sunny Island, Solarc, Schneider, Studer, and we're still developing closed loop with other battery inverter platforms at the 48 volt capacity. So, the eVolt will provide whole house backup. If you say, well, how do you do whole house backup with just one, 8 or 9 kilowatt battery inverter? Talk to our technical support department. We can provide some guidance on, how to design your automatic backup panel and also transfer manually the power from that to your home main service panel. So the right loads are automatically backed up and that you can still transfer over to any other load in your house, either intelligently or manually. There's solutions for that. Another new product that we developed quite recently is the Flex Rack. The Flex Rack is a cabinet for our eFlex batteries. It includes a bus bar, and it just makes a nicer cabinet, particularly in your northern installation locations. It becomes necessary to heat the batteries such as if you're storing them in a barn or in a garage or in a fishing cabin. You may want to leave the cabin but still have the solar array turned on, keeping the batteries full while running a heater just to heat the batteries themselves. The Flex Rack has a DIN rail mount for a thermostat heater to put into it, so that it doesn't come with the 48-volt heater, but it is an accessory that you can add to the 48-volt bus of the cabinet. So that Flex Rack is it's still an indoor application, but it will make storing the batteries and heating the batteries a little bit more easy. Of course, installers are still welcome to kind of rig up their own heating solutions, which can be as simple as putting a heating blanket around the battery in the wintertime, but it can be more professional than that too. Looking at the specs of the batteries, the E-Volt's 18.5 kilowatt hours, the E-Flex is 5.4 kilowatt hours. They're both 48-volt nominal batteries that operate, between 50 and about 54.4 volts. The E-Volt has a maximum discharge current of 180 amps, about 9 kW. The E-Flex will go up to 100 amps, so you see that increased discharge capability and peak output. If you look at our specs, we also have the recommended outputs. The intent is that these batteries are charged and discharged at a 2-hour rate, but they can momentarily go up to higher power levels. And we have different levels for that, for measured in seconds versus minutes. The E-Volt has a screen on it. The E-Flex doesn't. We do have tools to log into the E-Flex battery and see the individual stats that are really used on commissioning and maintenance. Inside both batteries, you have disconnects, you have relay contactors, you have fuses. Most code does not require a specific overcurrent protection or a specific disconnect for these 48-volt battery systems. Nonetheless, on the E-Volt, you have a double pole breaker, 250 amps that goes on and off. On the E-Flex, so the E-Volt has the breaker. The E-Flex has a push button rather than a breaker because it helps the E-Flex maintain that IP65 weatherproof case. It's a little bit more rugged of a design factor. Both batteries have 10-year warranties for over 6,000 cycles, so that's more than one cycle a day, which gets you through all kinds of peak and off-peak pricing structures. Even if you're charging the battery with solar during the day, discharge it in the evening, then charging it up off-peak at night, and then discharging it in the morning during a peak morning rate, all of that is covered under the Fortress warranty. These are 9540 certified batteries. That's the new, hard to get, often required by your local jurisdiction certificate. So both the E-Volt Max and the E-Flex are UL 9540 listed. So not all batteries on the market have that. That's the latest and greatest safety feature. So these are definitely markets that are intended to be bought by professional installers and installed in a professional manner. While we do get do-it-yourselfers buying these batteries, the primary market is to have a battery that an installer can stand behind the warranty on for 10 years. And we do all that warranty servicing regarding spare parts management or technical support out of our Northampton location. You'll just find some upgraded features in our batteries compared to the competition. Some nice looking, high quality enclosures that are designed to not only be good, but also look good. Inside the battery, our components are all top shelf, heavy duty, high voltage, high amperage components, with indoor and outdoor installation options. every component we select, we evaluate for their technical proficiency. With prismatic cells versus, say, cylindrical cells, you get a little more density, a little more durability, and a little bit more thermal stability. And so cylindrical cells are common when the manufacturer is putting the cells both into, say, the automotive industry as well as the home storage industry. When you get batteries that are made for dedicated home storage, you get prismatic cells. They should last a little longer, be a little bit more higher quality than pouch cells or cylindrical cells. And so it's these kinds of decision making process that says, well, how do you compare a lithium iron phosphate battery chemistry to another lithium iron phosphate battery chemistry? You know, the chemistry is 80% of how the product will perform. You know, the other 20% is in design, and that other 20% is, you know, the difference between the top shelf batteries and the bottom shelf batteries. So it's the shape of the cells themselves, and then it's the battery management system selection as well. You know, the biggest difference in battery management systems is that there are definitely low-end and high-end battery management systems. The difference is that low-end battery management systems use MOSFETs to control the energy. These are similar to the chips that are used in the solar industry for rapid shutdown management. You know, a solar circuit may be high voltage, but it's very low amperage. You know, a MOSFET is a low amperage device. A MOSFET, you know, that technology burns up at around 100 amps. And so a whole house, whole home backup battery at the 48 volt level is going to get above 100 amps in almost any backup application of any significant size. And so you run into problems with MOSFET-based BMSs, which are cheaper than digital processor-based BMSs, but you know, the saying goes, you get what you pay for. You know, you install a MOSFET-based battery management system, and then all of a sudden the battery charges at full capacity, you know, or the equalization turns on and you thought you disabled it, but a firmware update on the inverter end reset the settings and turned equalization back on. Now all of a sudden your battery is charging at the full inverter capacity. You know, or you get batteries that are at different voltage levels. Maybe the installer didn't check how full each battery was during commissioning and commissioned the batteries at different power levels. You start to get battery to battery backfeeding. You know, when you have 3 100 amp batteries and 2 are backfeeding 1, you know, your individual battery is beyond the capability of the MOSFET BMS, and that burns up. And so, you know, the Fortress BMS is an actual computer processor on a dedicated chip board that meets all the commercial requirements for high voltage battery systems in code, rather than, you know, we don't have to meet those requirements being a 48 volt battery system, but we still do. So that digital processor is related to high amperage, high quality components. The processor will contact independently the charging and discharging and pre-charging relays on the batteries, so that, you know, they manage charging and discharging independently through independent relays. That gets you more life on your relays, for example, so that the battery lasts the full 10-year duration and beyond. Closed loop control is another area where top shelf batteries stick out from the competition. This is where the battery management system itself is driving the inverter. It doesn't quite mean that you no longer have to program the inverter, but it does simplify the programming process. In particularly, you can program the inverter based off percentages rather than voltage levels. That's a little more consumer friendly, but it also allows you to get a little bit more performance out of the battery system. It's like driving a car with upgraded brake pads so that you can accelerate and decelerate more quickly when the battery talks directly to the inverter. When the battery doesn't talk directly to the inverter, the inverter is driving the battery usage, and so you have to have a little bit more of a, protective gloves on when you're dealing with the charge and discharge circuits. So that means you can get a little bit more power and operate more closely towards the maximum rating of the battery rather than the recommended rating of the battery, and still maintain the warranty when you have closed loop. So it is encouraged that you select an inverter that's compatible with closed loop control with the battery, although it's not necessary to, particularly with undersized batteries. So when you're doing, large off-grid camps, then the battery to inverter communication becomes less important because you have well oversized batteries. But when you have smaller batteries that are only designed to run a couple of hours for the whole house backup system, that's when that closed loop communication becomes more important. The main difference, though, is what the customer wants, not necessarily what the customer needs. Voltage-based controls are very precise for turning off the battery at low states of charge and preventing the battery from overcharging. But what the customer wants with closed loop control is to know what the battery state of charge is as a percentage rather than as a voltage. And so by selecting the closed loop control, the thing is, the battery percentage is very difficult to calculate. The voltage range on these batteries is pretty flat, much more flat than on a lead acid battery. And that's actually a good thing. What that means is even at a low state of charge, a lithium battery voltage is very stable. And that's why you can use, the full range of the lithium battery, whereas you can't with a lead acid. If you're using that lead acid battery under full load, but it's only at a very low state of charge, you're not going to get enough sustained voltage to run your load. Whether that's an intense charge for a short period of time or a large load, momentary load at the bottom of the state of charge, lead acid falls apart at heavy loads at low states of charge. The lithium, maintains its voltage level even in those low state of charge conditions. What that means, though, is from the 20% mark of the battery all the way up to the 80% mark of the battery, the voltage is very stable, and so it's hard to convert voltage into a percentage. The way you convert voltage into a percentage is you actually count the energy coming out of the battery at that voltage level and make a guess as to the state of charge. And the only way to do that accurately is to have a computer on the battery itself making that calculation. In the past, inverter manufacturers have used their inverter systems to make that calculation, but it's not accurate, and it's not as accurate as if the BMS is doing that calculation itself on the battery. Long story short, if the customer wants to know what the percentage state of charge is of their system and have that reflected as a percentage, not as a voltage level, select an inverter that has closed loop compatibility with our system. That way they can pull up the inverter monitoring system and see that percentage from the battery being communicated to the inverter. And so here in this menu setup of this one inverter brand, here you can see when we've enabled the percentage-based controls, we can program the inverter based off percentages rather than off voltage levels, and that's much more clear and straightforward for the system owner. And so closed loop control will provide accuracy, improved user experience, higher system output. As far as the brands go, we have closed loop support now with Schneider, Solarc, and SMA. Although the E-Vault will not do closed loop with SMA because of the nuances in the capabilities. The E-Vault Max will. And so Schneider, SMA, and Solarc, that's the Sunny Island series for SMA, we have closed loop support with. The other battery inverter manufacturers, there's a lot of Outback fans out there. Outback has great quality. Same with Magnum and Victron. You would just operate the battery in voltage-based control, and that is less of an issue in terms of usability and performance when the battery banks are well sized. The main technical advantage of closed loop is that it allows you to more safely operate an undersized battery bank. Now, there is a limit to that. At the end of the day, you don't want to have an undersized battery bank, but sometimes you'll see some flexibility there where if you have a closed loop inverter, you can get away with using 2 E-flex as the minimum. Whereas if you select the same size open loop inverter, you would have to do 3 E-flex to meet the minimum sizing requirement. And that kind of stuff, you're not going to get at first glance. And so when you're first becoming aware of Fortress and doing your first Fortress installs, we want you to email technical support, and we can give you a quick thumbs up or thumbs down if you're heading off in the right direction with your design. So here's E-Volt batteries with a Schneider off-grid system. We work closed loop with Schneider. Here's another configuration, a big off-grid rig with Sunny Island. The SMA also has a high voltage inverter. We do not yet have a high voltage battery. These batteries must be wired in parallel with each other. Often what that means is putting a combiner block of some sort in the gutter between the batteries and the inverters. The inverters have their own disconnects. The batteries have their own disconnects. We just put a bus bar inside the trough and combine them together. Here's Outback Radians. We see common installation. Often we see these a lot as retrofitting. It's very easy to swap out a lead acid bank at the end of its life with a lithium ion bank. There are some calculations you can make for minimum sizing requirements. And if you want just a quick thumbs up or thumbs down on our system designs, email tech support. We have a chat community you can join as well. But if you just want the quick and easy design, you can go to our website. Under our resources page, we have a minimum battery size requirement sheet where you can just look up the inverter number. You can look up our battery brand and say, okay, well, the minimum size of batteries is this many batteries for this configuration. Finally, on our website, we have a chat widget. You can ask questions into the chat widget. Those will be usually picked up by our sales and marketing team. But if they're heavy hitting questions, they'll be kind of transferred over to technical support. Over at technical support, we have a chat community called Discord. It's an app you can put on your computer as well as your mobile phone. If you sit behind a desk and you design systems all day, you'll love our Discord group because you can just join and text message with our technical support team, get a lot of information that way. If you have guys out in the field, they can put Discord on their phones, and that way they can send us pictures, that you can see what the conversation is between our team and your team. So you can have multiple people involved in the conversation and train up that way. So if you have questions about joining our Discord community, again, the starting point is just to send tech support at fortresspower.com an email, and then we'll get you the right information that you need. Finally, check out the resource center on our website. We put a lot of information there, our manuals, our spec sheets. We have some additional learning resources, for planning an E-Flex project, for just learning more about, intro to lithium battery fundamentals. We do have some NABCEP certified classes you can take on demand about battery sizing. We have a really interesting battery sizing tool that converts electric bills into a solar and battery project size that will break things out in terms of how much energy you're selling back to the grid versus how much energy you're keeping on site. That allows you to talk to customers in a manner that says, well, without batteries, your solar array, 2/3 of it is being sold back to the grid, 1/3 is sold on site. But if you add the batteries, then it's the opposite. You'll keep 2/3 of your energy on site and only sell 1/3 back to the grid. We can break that up into how many hours per day you're using grid power, how many hours per day you're using your on-site energy resource. And that way you can talk to customers in terms of, well, in the summer and the winter, you're using the grid for 4 hours a day out of 24, and then the rest of the time you're off grid. In the summer, in the spring and the fall, you're running completely off grid, with regard to your electric bill offset, and also help you break out how to manage that energy so that you can run more loads on smaller inverters and batteries during those true extended grid outages. So check out our resource center. We have a lot of not just our spec sheets, but some additional white papers that you'll enjoy reading through to learn more about design. We have a dealer center. Any installer, even if they're not planning on being a distributor, even if they're not a distributor, but installers and distributors both should fill out our dealer application. That will get you access to some in-depth resources that are really not public facing. Things like that sizing tool we were just talking about are available for members of our Discord community or our installer dealers. And so finally, we do a lot of aggressive email follow-up. If you send us an email, we'll get it and send a response. So the best way to contact tech support is to send an email to techsupport@fortresspower.com. The best way to contact sales is to email sales@fortresspower.com. Although we will probably just pass you off to a local distributor such as Bayware. So with that, I'm going to pass it back to Bayware, and I'm going to start looking at these questions, and then kind of we'll end the program doing some Q&A.
Thanks, John. That was great. I guess there are just a couple of questions here. I believe you answered this already. Do you have a high voltage battery, such as a 300 volt, that can be used with SolarEdge Energy Hub?
Yeah. We don't have anything that's high voltage or compatible specifically with SolarEdge. What I would say is stay tuned to SPI announcements in September on that, because we are developing a high voltage battery, but we don't have a release date for it yet. So stay tuned for that. Also, the SolarEdge system uses a higher voltage DC bus. And you have to be careful about how you get to that high voltage. Are you stacking batteries up in series to natively get to the high voltage, or are you putting a boost converter on your battery bank and artificially stepping up the voltage from the battery bank? Native stacking of cell voltages is much easier on the battery. And so when you look at not necessarily the SolarEdge platform, but maybe some of their competition, you might get a wider range of voltage operation. None of those higher voltage batteries are compatible with our product today. You really need to select within the 48 volt battery line, which again scales up to 80 kilowatt small commercial. You can power a whole house on a 48 volt platform and enjoy some of the safety benefits of that lower voltage system. But if you're already installing SolarEdge, you're going to have to do AC coupling for the time being. If you want to get into higher voltage battery inverters, again, check out our SPI solar conference announcements around September for an update on our high voltage battery.
Another question, are the batteries CSA or ULC certified?
I'm not sure if the UL is C designation is a typo or not. We do the UL listings, and so we have a UL battery 9540 battery, which is kind of the top UL listing. I think that will be equivalent to CSA, but I'm not certain. So if you need exact listing clarification, go ahead and send our tech support at fortresspower.com email for that.
Great. Where are your cells manufactured?
Yeah. So, I mean, almost all prismatic lithium iron phosphate cells are made overseas. One thing that is different about Fortress is that not only are our batteries made overseas, but we also have overseas dedicated employees and floor space in the cell manufacturer's facility. So this is a dedicated product line. It is not a product line that is just made by OEM and then slapped with a label on it. You know, it is our product line. It is our UL 9540 listing. And you know, when we do see any sort of quality issue in the field with our kind of aggressive technical support team, you know, we're getting a person to go look at the production line immediately, you know, within a day. So, you know, we ship, you know, hundreds of batteries per month. But if we get, you know, 2 technical support cases that are of the same issue within a week time, you know, we tell our quality manager and they're inspecting the production line for any issue. So we are a truly global company with employees all over the world, not just doing, you know, whether that's spare parts management, design, logistics, engineering, marketing and sales based out of the United States, or with our manufacturing facility, you know, actually having boots on the ground. You know, we check all those basics. So, you know, we kind of feel like a smaller, friendly company at Fortress because you can get people on the phone, and you know, we want to help you develop your battery business. You know, but we are a global manufacturer with a global supply chain.
Great. Which 12 to 48 volt AC to DC converter do you recommend for an RV project?
You know, a lot of RV projects tend to go with Victron, so we do see a lot of Victron support. But really, the batteries are compatible with any 48 volt products. You know, whether that be Midnight or Outback, or even smaller, lesser brands are fine. The main thing when we say, well, is this 48 volt component compatible with our 48 volt battery, that we look out for is whether or not the charging voltages are digitally programmed, or if there's like an analog dial where you just set it to the lead acid setting or you set it to the lithium iron setting. You know, there's one manufacturer out there on the market that's very popular, and they make very cheap chargers for better or worse. And so they're popular on the RV circuit. They're called AIMS is the brand, AIMS. And you know, not saying anything about whether the battery is suitable, battery product is suitable or not. You know, it generally is, but because the voltage levels are not programmed digitally, their product does not have a charging voltage profile that is in the right range for our 48 volt battery system. And the difference, the way you know that is they just have a dial that you can dial up and down rather than something you can digitally program. The lithium iron phosphate battery profile is different than the lithium cobalt battery profile. And whether the batteries have 15 cells in series or 16 cells in series will adjust that charging voltage by about 3 volts. And so, you know, being off on your charging voltages by 3 volts or even 1 volt on a long-term basis will cause the battery to degrade prematurely. So when we do have installs where someone puts one of our batteries with one of these Ames inverters, the solution is to disable the charger on the Ames inverter and then get a charge controller that's compatible, whether that be Outback or Midnight or Morningstar, as well as Victron. So even in the cases where the batteries are not quite compatible with the kind of the bargain bin inverters out there, you can still get a higher quality charge controller and use it with a lower quality battery inverter and have that be appropriate. So that should give you a couple of brand names to look into, and maybe Bayware can help out with some recommendations on that.
Have the batteries been tested to UL 9540A or plans to get this certification?
Yeah, we do all the testings. 9540A is a relatively new addition to the 9540, so we are in process of getting our 9540A certification. So feel free to send tech support email to get more information on those exact details, but we are getting the UL 9540A listing as well.
Great. See, one last question. Is it possible to do a system with AP Systems microinverters feeding 27 kW AC to the main grid power center?
Yeah. So the main question about retrofitting existing systems is that the inverter output of the existing system cannot be larger than the battery inverter output on the backed up or protected side of that battery inverter. So there's multiple sides to a battery inverter. There's the side that's connected to the grid, and then there's the output that's connected to the backup panel. And whether or not where you tie into solar, you can tie in as much solar you want onto the grid side of these systems, but it won't be there when the power goes out. So that's probably what you want, is to not just use the battery, but also use the solar array when the power goes out. But the problem you run into is over the last 10 years, the solar industry has been put as much solar as you can on the roof and sell as much back to the utility as you want. And sometimes that architecture doesn't meet up well with the battery retrofit, to say, well, these batteries require, for every kilowatt of battery inverter capability, you need about 2 kilowatt hours of lithium iron phosphate storage capacity. And so, if you have a 27 kilowatt AC system, to not have the solar array backfeed the battery inverter, which it's not designed to do, you would need a 27 kilowatt battery inverter. If you have a 27 kilowatt battery inverter, then you need a 54 kilowatt hour battery bank, and that starts to get out of the budget of not all customers, but many customers. And so what do you do in that case? Well, with microinverters, it's usually not that big of a deal because they're on multiple branch circuits. You could put, half the microinverter system on the backup side of the inverter and the other half of the system on the grid side of the inverter. And, while you would only be using half of the solar array during the extended outage, you still get the economic benefit of the really large array. And during the extended outage, you can get by with half of the solar array on solar arrays that are of that size. So with microinverter systems, the old adage goes that microinverters are very flexible, easy to design and install systems. That remains true. You can divide up the branch circuits in a way that you could put a 9 kilowatt battery inverter system onto any microinverter system, but only tie in one branch circuit of microinverters to it and keep the other microinverters as a supply side connection. Or you can do, 3 battery inverters, 3 Schneiders, 3 Outbacks, 3 Solarcs, and 3 E-Volts, and tie in the whole system onto the backup side. It's just a larger system rather than a smaller system. So that choice depends on your client. But the one nice thing about microinverters, as opposed to some of the string inverters, is there's, in phases, their AP System's main competitor is SolarEdge, and SolarEdge uses very large string inverters, like 10 kilowatt string inverters. A 10 kilowatt string inverter is harder to divide up compared to 2 5 kilowatt branch circuits. And so with a string inverter retrofit, you might find that you have to do larger systems for retrofitting existing solar string inverters than otherwise. So long story short, if you're doing a retrofit system and you want to tie the solar inverter into the backup side of the battery inverter, the solar inverter size has to be smaller than the battery inverter size to make sure that when the solar array is, backfeeding, that the amperage of the battery inverter is rated to take the full power of the solar inverter at full capacity. So anyway, if you want some more information on that, again, join our Discord group. We have some training classes that cover those basics, as well as transcripts and slides, and you'll learn a little bit more about that.
Great. I see that's it for questions. So thank you, John. Really appreciate you taking the time to help educate us all. Just a couple of notes. So this was recorded, so we will be sharing it during the July newsletter. So keep an eye out for that. If you need it before that time frame, just reach out to your sales reps. Also, if you have additional questions, your reps are there to help you out. All the specs can be found on our web shop, as well as availability. So those of you who have not signed up for the web shop, I would encourage that. It's an excellent tool in the tool belt for y'all. And once again, thank you for taking the time, and hope you're all taking care of there.
All right, thank you.